Land of contrast.
This advertising slogan, used so many times to highlight Andalusia's wonderful tourist attractions,
Land of contrast.
perfectly defines the biological and cultural wealth and the beautiful landscapes to be found in this region.
Land of contrast.
From frozen glacial peaks to subtropical Mediterranean coasts, from arid deserts and volcanoes to vast Atlantic wetlands, cork and holm-oak forests, pastures, olive groves, steep cliffs and endless beaches, steppes, landscapes that contain countless biological resources which make Andalusia a unique mosaic of biodiversity renowned throughout Europe. However, and this is something few people are aware of, each of these natural settings is also a different geological landscape with its own distinctive features, shaped by processes that have occurred over millions and millions of years, long before the human race appeared on this planet. Andalusia's extraordinary biological diversity is a natural consequence of its geological diversity, of its geodiversity. Man has not sculpted this natural scenery, these geological landscapes. He has adapted them and learned to live in them. Although adopted, we are the children of the mountains. In order to understand Andalusia's origins, we have to jump back in time to over 500 million years. During this period, the gigantic southern continent of Gondwanaland began a slow journey which would end 200 million years later in a collision with lands that had emerged in the north, thereby forming the supercontinent of Pangaea. The sediments deposited on the floor of the vast ocean that separated them were caught up in this huge collision and emerged, creating part of Andalusia, Sierra Morena, the southernmost sector of the Iberian Massif. Later, the single continent began to break up again, and to the south of the Sierra Morena, another sea opened, the Tethys, the predecessor of our present-day Mediterranean, on whose floor sediments thousands of meters thick accumulated. In this endless dance of the continental plates, around 30 million years ago a small piece of the Earth's crust moved from the Alboran zone westwards until it finally collided with Iberia and Africa. Thus another part of Andalusia was born, the Betic Cordillera. 10 million years ago, the rest of Andalusia was still sea. The progressive retreat of the water promoted by the uplift of the region caused the sediments accumulated on the seabed to emerge. Andalusia's geography finally took on the shape we know today around 2 million years ago. In order to reconstruct this amazing history spanning hundreds of millions of years, for over a century now, geologists have studied the most prominent features of each of these geological landscapes. This investigation reveals the keys to their history, small pieces of a gigantic jigsaw puzzle, the reconstruction of which provides us with an increasingly precise idea of the geography, the climate, and what life existed in those distant times. These revealing landscape features so important to us are our geological heritage. We shall discover this heritage in a tour of the most significant landscapes in Andalusia's 3 large geological units. Sierra Morena, the first large geological unit we are going to present, was born, as mentioned earlier, with the formation of Pangaea. As a result of being exposed for 300 million years, this area has undergone a slow but inexorable process of erosion, which has worn away its relatively flat terrain, creating low, gently undulating ridges. This means that its rocky outcrops are not particularly noticeable. However, despite this, it is still possible to use them to identify some extraordinary elements of Andalusia's geological heritage. One of these elements, the karst formation of Cerro del Hierro, or the Iron Mountain, is located in the northern mountains of Seville. Old limestone made up of reefs 500 million years old has been sculpted by water. This phenomenon is known as karstification, and the resulting sculpted rocks as karst or a karst landscape. In this case, the process also caused the formation of deposits of sedimentary iron, which gave the place its name. The hollowing out of these mineralized masses has helped make the sharp karst pinnacles stand out. The dissolving of the limestone has also created underground landscapes of extraordinary and occasionally unique beauty, such as the Gruta de las Maravillas, one of the most important tourist attractions in the Aracena Range. Another revealing enclave is located in the Despeñaperros ravine in the region of Jaén. Here's strata of quartzite, which came from coastal sands deposited around 400 million years ago, rise vertically as a result of the rock folding that occurred in this entire region. We can also see these strata in the river Guarizas, in this case folded and fractured by quite large faults, which gave rise to extraordinarily beautiful waterfalls, such as the Cascada de la Zimbara. The dark types of slate in the mountain ranges of Córdoba and Seville harbor more useful geological information. They are fossil records. Species of fauna and flora now extinct, which lived on the seabed 400 million years ago, and that tell us of the conditions for life in these remote oceans, very different from today's. In the Carboniferous period, some 350 million years ago, a very humid tropical climate favored the formation of vast swamps which supported dense forests of ferns and other plants whose remains accumulated and fossilized, forming generous deposits of coal. In Córdoba and the Guadiato coal measures, the exploitation of this natural resource continues today. At certain times during Sierra Morena's geological history, masses of magma rose from the Earth's interior. Today we recognize these as enormous intrusions of granitic rock, which gave rise to one of Sierra Morena's most characteristic landscapes, the Berrocales, which are areas covered with granite rocks. Volcanic fluids rich in metals mineralize the rocks in this region. The Iberian Pyrite Belt is a renowned mining district. It contains the sulfur deposits of Rio Tinto and Thasis, extracted by the Cartesians and the Romans for gold and silver mining, and since the middle of the 19th century to obtain copper and sulfur. Today, mining the deposits is no longer profitable, but they continue to be exploited, although now for a different purpose, as cultural and tourist georesources in an ambitious rural development plan for the whole of the former mining region. Let us now take a gigantic leap forward in time to the Andalusia of 30 million years ago. The collision of the Alborán plate with the Iberian Massif caused the emergence of what we now know of as the second large geological unit in Andalusia, and the first in terms of size, the Cordillera Bética, or Betic Cordillera. Its relief is structured in two large geological domains. The external zones, basically made up of rocks from the marine sediments, and the internal zones, consisting of old, highly deformed rocks which came from the continental plate that caused the collision. The Betic relief began to acquire a configuration similar to today's around 10 million years ago. Thus, it is almost 300 million years younger than the Sierra Morena. This is why it is in better condition, less eroded, and the landscape is more uneven, reaching 3,482 meters in Sierra Nevada, the highest point in the Iberian Peninsula. The relief continues to rise since the uplift continues today. The external zones can be identified by the characteristic limestone reliefs of mountain ranges such as the emblematic Maria, Cazorla and Segura, Subetic in Córdoba and Jaén, and the Grazalema Massif, reaching heights of up to 2,200 meters. Today, many of their peaks are protected because they have been declared natural parks. In reality, the external zones constitute a series of steep limestone mountains and valleys carved out of soft marls. Their marine origin is revealed in the rich marine fossil record, especially of a group of ancient now extinct cephalopods, ammonites, very distant relatives of today's squid, which possessed shells. Another of the most outstanding peculiarities of the Betic reliefs is their karst formations. Perhaps the best known is the Torcal de Antequera, a kind of stone city dotted with a series of fanciful and attractive rock formations. Some Andalusian karst landscapes are magnificent examples of other limestone landforms. The dolines, for example, are circular depressions that act as drains and channel the water to the underground karst. Sometimes they form extensive fields, the size of which can only be appreciated from the air. Occasionally, as in the case of the Pinar Negro karst in the Sierra de Cazorla or the peaks of the Sierra Gorda Massif, these fields are extremely spectacular because of the density of the dolines. Of similar origin to the dolines but larger are the polges, large karstic depressions generally closed with flat floors. These polges in the Sierra de Líbar in the Grazalema Massif, the Zafarraya polge in Granada, or the one in La Nava in the Subetic of Córdoba are examples of how spectacular and didactic these formations can be. The dissolving of limestone rocks generates a large number of cavities and deep sinkholes which channel water to large subterranean reservoirs and occasionally give birth to rivers, such as the Guadalquivir. There are over 4,000 cavities in the Andalusian catalogue. Many of them are of great speleological interest and some of notable archaeological value. We can enjoy the attractions of the underground world and those that can be visited, as in the case of the historical Nerja cave, one of the main tourist attractions on the coast of Malaga. The forceful channeling of the river network and the dissolving processes sometimes create deep, narrow gorges, such as the Desfiladero de los Gaitanes, one of the most impressive in Andalusia, situated at the outflow of the river Guadalhorce reservoirs in Malaga. The coastal ranges of the south of Cádiz constitute an intermediate unit between the external and internal zones. They offer natural landscapes as revealing as those that form the relief in the Los Alcornocales Natural Park and the coastal area of Algeciras Tarifa in the Straits of Gibraltar Natural Park. The internal zones of the Betic Range, the remains of the continental plate that collided with the Iberian Massif, are made up of different landscapes. To a certain extent, they resemble those of the Sierra Morena because of their intensely deformed rocks, although they are younger. They form steep and high reliefs, in particular Sierra Nevada, Filabres, and the coastal reliefs of Malaga, including the unique peridotite massif of Ronda. In the high peaks of the Sierra Nevada, ancient glacial systems can be seen. Now disappeared, they covered the south of Andalusia during the cold periods of the Quaternary. Cirques, glacial valleys, lagoons, and a large number of other small erosive forms bear witness to the fact that the southernmost glaciers in the old continent were present in Andalusia. They allow us to reconstruct the image of a Europe with high peaks formed from north to south by permanent ice. Around 10 million years ago, the sea was still invading extensive low-lying areas of inland Andalusia. After its retreat, the marine sediments deposited were uncovered, forming the third large geological unit in Andalusia, the Neogene basins, a term that alludes to their recent formation, at least on a geological scale. The relatively recent formation of these sediments means that they have practically no deformation and an abundant fossil continent, still almost fresh, which is an exceptional testimony to the evolution of life during this period. The erosive processes associated with the channeling of the drainage network are responsible for the shaping of forms as similar as meanders and river terraces. Mountain tables, splendidly represented in Setefilla, or gorges of extraordinary beauty in Arcos de la Frontera, majestic in Ronda. These natural cliffs also reveal the recent marine past of the region to us in their strata. When the rivers meet the Atlantic Ocean between the provinces of Huelva and Cádiz, we find the most dynamic area in the whole of Andalusia from a geomorphological point of view. Let us stay with this vast coast dotted with wetlands, beaches and cliffs of singular beauty and consider some of the most important geological landmarks. They are all emblematic elements of the network of protected natural spaces in Andalusia. Enclaves which also reveal the evolution of the Atlantic coast during the Quaternary period. Along the coast we can see extensive active dune fields fed by the wind with sand being carried from the beach or from the destruction of the sandy cliffs. In Doñana we can see how different generations of dunes succeed one another, slowly invading the inland marshes. Ancient beaches and dunes, today fossilized, create obstacles that have favored the formation of tombolo structures such as the one at Cape Trafalgar. Barriers or spits whose growth is observable on a human scale enclose huge estuaries. Perhaps the most spectacular is the one at El Rompido, which provides shelter for the River Piedras and the spit at Sancti Petri wetlands, which along with the marsh, marine terrace and island make up a unique, exceptionally beautiful coastal complex. In these wetlands, all kinds of active landforms can be found, in which fluvial and littoral processes converge and mix with equal intensity. Apart from the Guadalquivir basin itself, other depressions within the Betic Cordillera were first flooded by the sea and over the course of time occupied by vast continental lakes and were finally silted with sediments. The Granada and Guadix-Baza depressions and the coastal depressions of Almeria are some of the most important due to their size. The shores of the Quaternary lakes must have provided a wealth of resources for animal life. In the most recent lake sediments, we find extremely important paleontological deposits such as those in Orce, with remains of large European vertebrates from around 1.5 million years ago, and even traces of early man, the earliest human remains ever found in Europe. There was intense volcanic activity in Almeria during a period between 14 and 7 million years ago. Today we can see the remains of this process in the part no longer covered by the sea, the Cabo de Gata volcanic complex, which is associated with mineral deposits as unique as the famous Rodalquilar gold. Between the volcanic mountains and the sea, Quaternary spits have protected one of the best conserved examples of a Mediterranean lagoon, which has been converted by man into saltworks, the Cabo de Gata saltworks. The coast of Almeria marine basins was colonized by coral reefs. Now fossilized, these reefs can be found quite a few kilometers inland. They tell us about Almeria's tropical climate 6 million years ago and allow us to reconstruct the geography of Almeria during this geological period. These marginal marine basins, just like the whole Mediterranean, dried out around 5.5 million years ago. This unusual phenomenon caused the deposition of enormous masses of gypsum and other salts on the seabed. In the case of the Sorbas Basin, once the gypsum had been uncovered, the rain and underground water shaped one of the most important subterranean geological landscapes of this type in the world. This is known as the Sorbas Gypsum Karst, and we are also fortunate enough to be able to visit it, guided by expert speleologists. The formation of the Guadix-Baza and Tabernas basins was no less spectacular. Torrential rains sculpted their soft sediments until it created a desert in southern Europe, or perhaps we should say in North Africa. At any rate, this natural museum of shapes and processes would be difficult to find anywhere else. It is an open-air laboratory of incalculable value which can increase our knowledge of one of the most serious environmental problems threatening us today, desertification. The enclaves that we have just seen form part of Andalusia's geological heritage. The information they offer has made it possible to contribute to reconstruct the history of the formation of our Earth. However, almost all details still remain to be discovered. And we have simply only just begun to scratch the surface. Human beings are the only animal species on the face of the Earth capable of revealing the mysteries of the evolution of our planet. Future generations will achieve this if we preserve the keys to this information for them, our geological heritage. Unfortunately, we are also the only animal species capable of making it disappear. If this occurred, we would continue in our ignorance forever. It is our responsibility to avoid this happening.